Hey everybody, in this video we're going to be talking about the unit circle. So since we already know a bit about 30, 60, 90 triangles and 45, 45, 90 triangles, we're going to utilize them and their properties to build what we refer to as the unit circle. It's going to be really essential for progressing our mathematical knowledge and really developing a good understanding of trigonometry and sinusoidal functions. So in this case, we're discussing the unit circle as a unit circle because the radius of our circle we will say to be 1, or a unit radius. Okay, so no matter what point you're at on the circle, right, whether it's here, here, or here, we will always have a radius of 1. So that is the distance from the center of the circle to any point on the circumference of the circle will be 1. Okay, so I've drawn out a couple lines in the first quadrant of our circle. We can think of a circle as being broken into 4 quadrants, split between the what do you say, perpendicular bisectors that fit within the circle. And we want to look at these as 30, 60, 90 triangles and a 45, 45, 90 triangle kind of interlaid into the circle. Okay, so I've separated these out to the side, and since we know this is a unit circle and any distance from the origin to the circumference is going to be 1, we can go ahead and say that all of these distances are 1. Okay, and that's going to be important for determining what are the lengths of the other legs of each of those triangles. Okay, so for the 30, 60, 90 triangle, that's going to be our first point right here. We want to look at what are the other 2 legs based off of the hypotenuse of 1. Okay, so we know that the shorter length leg of a 30, 60, 90 triangle is going to be opposite the 30-degree angle. Furthermore, we know that the leg opposite the 30-degree angle is going to be 1/2 of what the hypotenuse is. So given that the hypotenuse is 1, we can go ahead and say that this length is 1/2. Okay. Furthermore, we also know that the longer leg is going to be opposite the 60-degree angle. Draw the 60-degree angle in blue, and it's going to be √3/2 times the hypotenuse. Okay. Or you could say √3 times the smaller leg of the triangle. Okay. And that's going to be, in this case, √3/2. Okay. So there is a setup for the 30, 60, 90 triangle that we'll label right here at that point. Okay, so with that in mind, we can look at these as kind of like x and y coordinates, thinking of the unit circle as being overlaid on a coordinate system. And we would consider the origin to be the center of the circle, and we consider the horizontal distance from the center of the circle to be our x values. So in this case, we'll have √3/2 being our x value, and then we consider any vertical distance that we go up from that horizontal axis to be our y values, and in this case, we can say 1/2 will be our y value. So given this 30, 60, 90 triangle overlaid into the unit circle, we can say that the point on the circumference of that 30, 60, 90 triangle will be √3/2 for our x value, and then 1/2 for our y value. Okay. That's just straight from the triangle that we built. Okay, so I'm going to go ahead and do this, in a sense, 60-30 triangle, which will be this point up here relating to this point over here. And we know that the hypotenuse is still 1, same unit circle. We can say that this upper angle is going to be our 30-degree angle measurement, and this base angle will be 60-degree or 60-degree angle measurement. So by symmetry, we can go ahead and fill these in as 1/2 and √3/2 by the same justification. Okay, so still understanding that this point right here is going to be the center of the circle, we'll determine 1/2 to be our x value, okay, and then √3/2 to be our y value. Right, so we can go ahead and put some ordered pairs for this point on our unit circle. We'll say our x value is 1/2, okay, and our y value is √3/2. Okay. Now onto the 45, 45, 90 triangle. If you guys remember from the last video, we have our hypotenuse, in this case will be 1. Either leg of a 45, 45, 90 triangle will be root 2, let's see, it will be root 2 over 2 times the hypotenuse. Okay, so in this case we can see that for a hypotenuse of 1, we'll have root 2 over 2 for our value on the vertical distance, and root 2 over 2 for the horizontal distance there. Okay. So in that sense, we have an x coordinate for the 45, 45, 90 triangle as root 2 over 2, and then we have a vertical component or y coordinate for our 45, 45, 90 triangle also as root 2 over 2, and that will give us that point. So going back to our unit circle, we can overlay that into the picture, and we see that the x coordinate for our 45, 45, 90 triangle in the first quadrant of our unit circle will have coordinates for the ordered pair of root 2 over 2 and root 2 over 2. Okay, so that's going to be essential for building the rest of the important values that are within the unit circle. We've got the most complicated ones down. The other two that may be worth mentioning would be a value of 0 degrees, which would be essentially the x-axis of our unit circle, and we can see this to be the point 1 for an x value and 0 for the y value because we're not going up or down. And then for the vertical top point on our unit circle, we can see this to be a 0 x value since we're not going left or right from the origin, and a 1 y value because that 1 y value will be our radius since we're going directly from the origin to the top of the circle, and we'll see that coordinate to be 0, 1. Okay, so what I want you guys to do is to go ahead and fill in the rest of the values for each of these angles, right? So by symmetry, we can see that we'll have essentially 30, 60, 90 triangles interlaced everywhere in this unit circle, okay? And it's going to be really important for understanding the the degree measurements and x and y values, which we'll get to with sine, cosine, and tangent functions, to know these really well down pat. So I'll go ahead and help give you guys an idea of what we're looking for one. Right? So let me get out of the shapes. So for this value right here, we want to see what is this coordinate pair. Okay. And if you think about it, it looks an awful lot like this coordinate pair, the 1/2 root 3 over 2 from our 60, 30, 90 triangle, right? That's going to be the one down here, okay? And we note that the horizontal distance is going to be the same. The vertical distance is going to be the same. So you can look at that as a y component of root 3 over 2. Okay. And furthermore, since we know it's the same 60, 30, 90 triangle, 30, 60, 90 triangle, by dropping an altitude there to see that this angle will be 60 and then this angle will be 30, we can understand that the y value, the x value will be 1/2. So that this will be 1/2. But notice since we overlaid this unit circle onto a coordinate plane, we are now going to the left of the origin. So we're going to want this value to be negative. Right? So in this case, any value in the second quadrant, it's going to be any value along this edge of the unit circle, will have a negative x coordinate and a positive y. Okay. So any value in the third quadrant, it's going to be living down here, will have a negative x and a negative y. And then any value in the fourth quadrant, which we'll consider to be this section, will have a positive x-coordinate and a negative y-coordinate. So I want you guys to go ahead and work through the exercise of building your own unit circle and see what you can realize. Thank you.